Hey guys, it's Miss Bailey, and for today's lesson we are going to be learning about plate tectonics. So let's get into it. So for bell work today, we are going to write about a time you have seen or felt an earthquake. It can be in real life or on a show/movie. So pause the video here, do your bell work, and then we will jump into the lesson. So for our SMART goal today, we want to be able to, by the end of the lesson, you'll be able to describe 3 boundary types and their effect on the earth for your upcoming assessment. So what are plate tectonics? Plate tectonics are big slabs of rock that move about freely on the lithosphere, basically huge, giant chunks of rock that move freely on something called the lithosphere. The lithosphere is basically kind of like Cool Whip, which we'll see in a little bit, that they float on top of it, but they're not stuck on it. Like, they can still move on top. There are 15 total plates, 7 major plates and 8 minor plates. As you can see here, the black lines outline the plates, and as you can see, they kind of, follow the same shape as the continents. So something that's really cool about the continents, there's a theory called Pangea, where all 15 plates were once joined together, as you can see in this picture. Evidence of this is that they have a jigsaw fit. As you can see, they look pretty packed in together with a good fit. There are fossils found across continents. For example, Africa, there was fossils found where they knew that the organism couldn't swim across the ocean, and they were found in the Eurasia plate, which is now separated from Africa. So they were like, how would that be possible if 2 of the same fossils were found on different continents? So they assumed that they were once all conjoined together. Another piece of evidence is that there are same rock types and mountain ranges that line up across the different continents when they were once together. So if they were once together, now they're separated, we want to know how the plates move. So the plates move on top of the lithosphere through a process called convection currents. Now, convection currents occur when magma rises, and then once it cools, it gets more dense and then falls. So it's a big process of like currents going in a circular motion, and the plates move 1 to 20 centimeters per year, and they've kind of proven that it moves at the rate of your fingernails growing. So as you can see here, we have the circular currents moving as the hot magma rises, and then it cools and becomes more dense and falls. And this happens in the mantle, which allows the lithosphere to move with the plate tectonics on top of it. So there are 3 types of plate boundaries, and plate boundaries are when 2 plates meet up together at a certain point. So the first type is convergent plate boundaries, and those occur when 2 plates collide, they go in together. Divergent plate boundaries are when they move away, pull apart, and then transform is when they move past each other, kind of like that. Okay, so we'll dive into each one. So within convergent plate boundaries, there are 3 types: ocean-continental, ocean-ocean, and continental-continental. As you can see here, there's an example of each type. So, ocean-continental, that is when oceanic crust and continental crust collide together. And when this happens, there's a special thing called subduction zones, which happen when the denser oceanic plate subducts underneath the continental plate, making a trench, as you can see here. So actually, when this happens, the oceanic crust goes beneath the continental crust, goes into the mantle, which then the crust melts. It forms into magma, and then if the magma gets enough pressure to go up and up and up, it creates volcanic arcs. As you can see here, the magma then spews out and becomes a volcano. So that's basically the three things that happen and the effect on the earth are subduction zones, trenches, and volcanic arcs at ocean continental. Okay, continuing on, we have ocean, which occur when two oceanic plates collide, because that's what convergent is. And those can create basically the same as ocean continental volcanoes, where the more dense oceanic plate goes underneath and that crust melts and the mantle becomes magma, and then it forms volcanoes, but those happen in the ocean, not on land. With that, they can create islands, because if the volcanoes eventually break the surface of the water, they can form land. As you can see here, we have the Aleutian Islands, which formed from ocean continental, ocean convergent. Those formed in the middle of the ocean, and they are a part of Alaska. Okay, so the last type of convergent are continent. That's when two continent plates move and collide with each other. So this can create volcanoes as well, and it also creates mountains. That's probably one of the main elements of continent. So you can see both plates moving into each other, and they collide, and they can't do anything except go up. So they go up and create mountain ranges, and one of the most famous examples of that are the Himalayas, which are a huge mountain range. Actually, it has the highest peak in the world, which is Mount Everest. I'm sure y'all have heard of that. So yeah. All right, now I have a question for y'all. What type of convergent plate boundary creates a subduction zone? All right, you can pause the video here, discuss with someone next to you, write it on a piece of paper, whatever you want to do, and we'll get back in a little bit. All right, now we're going to dive into divergent plate boundaries, and there's two types. We have ocean and continent. So the first type, ocean, that's when two oceanic plates pull apart from each other, which is crazy, but it happens. So as you can see here, they're going separate directions, and it creates something called a mid-ocean ridge. Now, mid-ocean ridge is, you can see here, plate 1 and plate 2 are pulling apart. It allows for the magma to rise up into that little valley that was created, and then it cools once it hits the surface, and it actually creates new crust, as you can see, because it allows for more space for the magma to come up. So once it cools, it creates new crust, which is actually pretty cool, and that's ocean. Now we have continent, and it basically does the same thing, pulls apart, but just two continent plates, and it creates things called rifts. Now, a rift is when two continent pull apart, and it creates new crust as well. As you can see, the magma is rising up, it cools, new crust is created, and that actually gives room for a new ocean basin. As you can see, the water kind of flows in there, creates new oceans. And the best example of this is actually the Red Sea, which is what this picture is right here. So you can see the two continental plates spread apart, and then the water kind of formed its way in there. So now for the last plate boundary, we have transform, and there's only one type, and it's continent. Remember, that's when they go back and forth. So with this, they make things called faults. Now, faults are, when the two plates move back and forth like that. But when the faults kind of give out and the friction gives out, it creates an earthquake. So basically there's a lot of friction, then eventually it like gives out basically, and it creates the ground moving, which is an earthquake. And the best example, and it's right here in the US as well, is the San Andreas Fault, and that's in California. And actually, Los Angeles is due for an earthquake because they haven't had one in a while, and so they think that the fault is about to give out, which is crazy. So, another question. What type of boundary creates earthquakes? Now, you can pause the video again, write this down, discuss with someone next to you, and then we'll get back to it. Okay guys, now it's time for the best part. We have learned everything that we needed to learn, and now for our guided practice, we are going to be doing a lab. Now this lab you can do at home with pretty much everything you can find in your pantry or your fridge, just household items that we will use to simulate the different types of plate boundaries and what they can make. So let's do the lab. Hey guys, what's up? We're here in our lab, and to start off, I am going to show you all the ingredients. It's really simple stuff you can find at home so that we can all do this lab together. So the first ingredient that we're gonna use is graham crackers, and the graham crackers are going to simulate the continental crust. As you can see, we have it in squares. You just break it in half. Next, we have the fruit roll-ups, which are gonna simulate the oceanic crust, and what you do is you unwrap it, and then you cut it into fourths. So it's basically the same size as the graham crackers. And then next we have Cool Whip, which is going to simulate the lithosphere, like we said in the PowerPoint. And then we just have a cup of water that we're gonna need during the experiment. So to start off, we're gonna put all of our ingredients over here. I'm gonna keep the water though. So to start off, here we have our setup. Now, we have our fruit roll-up, our graham cracker, and then we have about 2.5 by 2.5 square that has probably like 1/2 inch thick of Cool Whip, and that is representing our lithosphere, and you'll see why in a second, because you know the plates still float on top of it, but they can move still. So we have all of our simulations for the different types, as you can see here. So yeah, so we'll just dive right into it. So the first one we're gonna do continental oceanic convergent. Now, if you remember from the notes, so we're just gonna set those right on top, and as you can see, they can move freely because that's what the lithosphere does. So as you can see, if you remember from the notes, the oceanic crust, which is more dense, goes underneath the continental crust in convergent. So convergent, you move together. So we are gonna move these two together. And if you notice, the oceanic is gonna go underneath and the continental is gonna go on top. Now, if you remember from the notes, we have our trench here. And then the oceanic crust is going underneath and heating up and turning into magma and all the good stuff. So that is our first one. Next, we have continent convergent. So we have our thing of Cool Whip, we have our two continental crust. So for this one, if you remember convergent, they create mountains when they go next to each other. So what we're gonna do to help simulate that is dip the graham crackers in water for about 3 or 4 seconds. That's good. And then we're gonna put the two wet edges, and we're gonna just let them go close to each other and let the mountains form. And as you can see, I don't know if you can see that, the mountain was formed, the mountain range, when the two collided together, and it just keeps building and building like we saw in the PowerPoint. So that's cool. Okay, so we are going to do divergent now with the two continental. And if you remember, this one is when they pull apart and allows for the oceanic basin to come in, like the Red Sea. So here we have the two continental crusts pulling apart, and it's kind of creating a basin. As you can see, there's kind of room for the water to come in and create new ocean, which is fun. Okay, next we have the other divergent, which is oceanic. And if you remember, oceanic divergent boundaries make mid-ocean ridges, and that is when it creates new crust. The magma comes up, it cools, creates new crust, you know. So basically, we're gonna set them in the lithosphere and pull them apart, as you can see, and it's kind of doing the same thing, where it's kind of creating a little valley where the ocean can make new crust. So that's fun. Next we have ocean convergent, which makes the islands out in the middle of the water, which is fun. So what we're gonna do is put them together and then move them up, and then it's going up. I don't know if you can see this, going up, 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 and then eventually it's gonna break the surface of the water and have that nice island in the middle of the ocean. So, and that's basically how it happens. As you can see, nice mountain in the ocean, or even volcano. So, last but not least, we have our transform with our two continental crusts. So, if you remember, this one is where they make faults, make earthquakes. So it's really fun to see in the Cool Whip that when you move it, here, I'll try to show you, back and forth like this, and you create more friction, more friction, more friction, then boom, they kind of, you know, break, and it starts moving, the earthquake is happening, you know, it's really fun, and really fun to simulate it as well, so you can see it, you know, kind of first person, what happens when these occur in real life. So I hope you enjoyed this lab. It's really fun, really easy to do at home with ingredients you can find in your home. You know, if you don't have Cool Whip, maybe you can use shaving cream. That's a good option. There's lots of stuff that you can use to simulate the plates as well. So yeah, this is a really fun way to just simulate that. So yeah, that's the lab. I hope you enjoyed. Hey guys, I hope you enjoyed eating your lab because it was very yummy. But time for a little bit of an assessment. So now that we have done our notes, done our lab, it's time for a little bit of independent practice. So on a sheet of paper, I want you to write your answers to the following questions. You don't need to write the questions, I just need the answers to your these questions. And I also need at least 3 sentences for each answer. So 1, how does the subduction zone work and what plate boundary does this occur at? 2, explain the difference between each of the 3 boundary types. And 3, which is kind of fun, you can play around with it, it is If an earthquake was to hit your city, create a plan of preparation and evacuation. So you can pause the video, do your 3 questions real quick, and then we'll get back to it. All right, conclusion. So we are going to watch a little 2-minute YouTube video just to wrap up plate tectonics, make sure y'all understand it real well, and then we'll ask questions in the end. So let's watch this video. Okay guys, here is the video.
The idea that our planet's continents drift around the globe, periodically glomming together and breaking apart, is at least 200 years old. But most geologists didn't believe it until the 1960s, when mounting evidence made it clear that the Earth's crust is broken up into fragments, and that those fragments, called tectonic plates, are moving. And these days we directly track that motion, with millimeter precision, from space. The common simplified explanation for why tectonic plates are moving is that they're carried along on currents in the upper mantle, the slowly flowing layer of rock just below Earth's crust. Converging currents drive plates into each other, diverging currents pull them apart. This is mostly true. Hot mantle rock rises from the core and moves along under the crust until it grows cool and heavy and sinks back down again. But the plates aren't just passively riding these currents around like a bunch of suitcases at the baggage claim. They can't be, because some of the plates are moving faster than the currents underneath them. For example, the Nazca Plate, a chunk of ocean crust off the west coast of South America, is cruising eastward at about 10 centimeters per year, while the mantle underneath it oozes along at just 5. Neither tectonic plates nor luggage can move faster than the belts they're riding on unless something else is helping to push or pull them along. And some of Earth's plates, it turns out, are pulling themselves. When an ocean plate collides with another ocean plate, or a plate bearing the thick crust of continental landmasses, the thinner of the 2 plates bends and slides under the other. As the edge of the seafloor sinks into the mantle, it pulls on the plate behind it, the same way a chain dangling further and further off a table will eventually start to slide. The bigger the sunken portion of the plate becomes, the harder it pulls and the faster the remaining plate behind it moves. You can find where this is happening just by looking at Google Earth. The incredibly deep, narrow ocean trenches visible off the coasts of some continents and island chains mark the creases formed as ocean crust plunges downward, bending the edge of its neighbor in the process. What's more, these chunks of seafloor are actually helping to drive convection in the mantle beneath them. Sunken slabs of ocean crust block flowing rock from moving further sideways, forcing it to turn downwards and sink. And eventually those slabs get too heavy and break off, plunging slowly toward the core and creating a suction force that pulls mantle material along behind them. So in some ways, seafloor crust is really more like part of the conveyor belt than something riding on top of it. The continents, on the other hand, are baggage.
Okay guys, I hope you enjoyed that video, and I hope it cleared up some of your confusion maybe. Other than that, that is it for plate tectonics. I hope you learned a lot today, and yeah, thank you for watching.